So here's the weird part that should make you stop and think. Right now, every time ChatGPT writes you a sentence, it's guessing one word at a time. Actually, not even full words, it's guessing fragments of words called tokens. It's like watching someone write a novel by playing the world's most sophisticated game of Mad Libs, filling in one blank at a time with no ability to change what came before. And somehow, this clunky, sequential process has convinced us we're on the brink of artificial general intelligence. But here's what just landed from Tencent and Tsinghua University that flips this whole picture upside down. They built an AI called COM that doesn't think in tokens at all. It thinks in continuous mathematical vectors that each represent roughly 4 tokens worth of meaning at once. And the kicker? It's 44% cheaper to train than the systems we're currently using, and it actually performs better on long, complex tasks. So if we've been getting decent results from AIs that think like they're playing Mad Libs, what happens when we let them think in complete ideas instead? Let me unpack why this is genuinely strange. The entire foundation of modern AI, everything from GPT to Claude to Gemini, runs on what's called autoregressive token prediction. That's the fancy way of saying the AI reads your prompt, then predicts the next token, then uses that token to predict the next one, then uses those two to predict the third, and so on in this rigid, linear chain. It's fundamentally sequential. It can't go back and revise. It can't hold a full thought in its head and then express it. It's committed to each micro decision as it makes it. Now, this has worked shockingly well, better than anyone expected, which is why the entire AI industry has been doubling down on it, building bigger models with more tokens, more parameters, more compute. But here's the thing. We've always known this approach is inefficient. Humans don't think in tokens. When you're telling me a story, you're not selecting each word independently based only on the words before it. You have a sense of where the story is going, the emotional arc, the punchline you're building toward. You're thinking in ideas and then translating those ideas into words. COM is attempting to do that translation at the architectural level. Here's how it works, and this is where it gets fascinating. Instead of predicting discrete tokens, COM predicts continuous vectors in a high-dimensional space. Think of it like this. A token is a specific point. The word cat is one exact spot on a map. But a vector is more like a region, a neighborhood that contains related meanings. One vector might encompass cat, feline, kitten, and tabby all at once, along with the subtle contextual shading that determines which specific word eventually gets chosen. And here's the magic. Because these vectors are continuous rather than discrete, the model can represent roughly 4 tokens worth of semantic information in a single prediction step. That means it takes a quarter as many steps to generate the same output. Fewer steps means less computation, which means you can train it faster and cheaper. 44% cheaper, according to their benchmarks. And that means something concrete for you and me. Right now, the cost of running these AI systems is the main bottleneck preventing them from being everywhere. Your therapy chatbot, your personal writing assistant, the AI tutor for your kid, they're all limited by how expensive it is to serve millions of people making billions of queries. When someone slashes training costs by nearly half and makes the models faster at inference too, that's not just an academic improvement. That's the difference between AI being a premium feature for people with corporate accounts and AI being genuinely democratized, baked into every app you use, accessible to every creator who can't afford a team of writers or marketers. This is the kind of efficiency gain that changes who gets to use these tools. But here's the thing, and this is the counterintuitive part that the researchers themselves are grappling with. We don't actually have great ways to evaluate whether this approach is working. Our entire measurement system for language models is built around perplexity, which measures how surprised the model is by the next token. But COM doesn't predict tokens, it predicts vectors. So perplexity doesn't mean anything anymore. The researchers had to invent a whole new metric called BrierLM, borrowed from probability forecasting, just to measure whether their model is improving. And when they ran the comparisons, COM outperformed traditional transformers on long context tasks, but we're still in early days. The largest COM model they've tested is relatively small compared to the frontier models from OpenAI or Anthropic. And here's where the real tension lives. Over on Hacker News and the machine learning subreddit, you've got enthusiasts calling this the brain-like breakthrough we've been waiting for. The move from discrete symbols to continuous thought that gets us closer to how biological intelligence actually works. Then you've got the skeptics, and they're not wrong to be skeptical, pointing out that continuous models are fundamentally harder to debug. When a token-based model fails, you could trace back through the exact sequence of choices it made. When a vector-based model fails, you're looking at a smooth gradient in high-dimensional space. Good luck figuring out what went wrong. It's the classic trade-off between power and interpretability. And there's another wrinkle here that's worth sitting with. If COM really does think in bigger conceptual chunks rather than word fragments, that changes what kinds of tasks it might excel at and what it might struggle with. Token-based models are weirdly good at wordplay, at puns, at noticing when two words rhyme, because they're hyper-focused on the surface form of language. A model that thinks in meaning vectors might be better at grasping narrative structure or logical consistency over long spans, but worse at the low-level linguistic tricks that sometimes matter. We don't know yet. The paper is brand new, the code isn't widely available, and nobody's had time to really stress test this in production environments. But the fundamental insight is hard to ignore. If you can compress 4 tokens worth of information into one prediction step without losing quality, you just made AI dramatically more accessible, and you've opened the door to models that genuinely process longer contexts more coherently. That's not hype, that's geometry. The question is whether the approach scales and whether the industry, which has invested billions in token-based infrastructure, has any appetite for ripping up the foundation and starting over. So here's what this means for you tomorrow. If COM or approaches like it prove out over the next year, the AI tools you're using are about to get faster and cheaper, which means they'll get embedded in more places. Your real-time voice assistant will lag less. Your writing tools will handle longer documents without losing the thread. And maybe, just maybe, the cost curve bends enough that the next wave of AI-powered creativity tools doesn't require a subscription that only professionals can justify. We're watching a potential paradigm shift happen in real time, and the human consequence isn't some distant sci-fi future. It's whether the AI you interact with next year thinks in clunky token steps or in something closer to fluid ideas. Subscribe to Neural Nuggets for the latest updates in AI.